guys, in this example, block A has a mass of m and it's released from rest. And it falls a distance h before striking the plate B having a mass of 2m. So before, guys, collision, A was here and it's moving. It has a free fall from this point to this point, right? So it has a free fall along each. If the coefficient of restitution between A and B is E, so I know E, I need to determine the velocity of the plate B just after collision, all right? The spring has a stiffness K. Do you think that this K is useful here, guys? Do I need to know this K? In fact, not. No, because in fact, guys, if the problem was that this B is compressing the spring and then it's jumping and then the collision occurs, I should find the velocity of B before collision. But here in this example, B is resting on the spring, which means I don't need K. K is useless here, right? So this is a simple example, but before applying the impact, I have to find the velocity of A before striking B. All right, so guys, before applying the equations of impact between A and B, and in fact this is a central impact, I should find the velocity of A just before impact, which means after really falling the height. H. How, guys? How? The easiest way to find the velocity of A just before collision is in fact by applying the conservation of mechanical energy between, of course there is a lot of other methods, but this is the easiest one, between A0 and A1, right? I mean by A0 here, this one, and A1 just before collision. Okay, so let's apply this. TA, so this is only for the mass A, plus VA is equal to TA plus VA. Now, this will be at state 0. And this would be at state 1. And remember, V here is not the velocity, it's the potential energy. I know that TA0 is 0 because it's falling from rest. And I should specify the datum so that I can, in fact, find the energy, the potential energy. I'm going to specify this as my datum. Of course, you can take this one. It's the same, but in this case, H should be negative. Now, in this case, H should be positive. All right. So here, I'm going to have MGH is equal. Now, this will be 0 half MV squared A1. All right. So MGH will be equal to half MVA1 squared. And this means, guys, that VA1 will be positive or negative radical of 2GH. Now it's up to you. You can take the positive direction as the positive Y. And in this case, of course, VA1 will be negative because A is moving downward. Or you can take this as your positive direction. I'm going to take this as my positive direction later on, to use it later on in the impact equation. And I'm going to call it Y prime. Right? So if I take this as my positive direction, then VA1 will be positive. Right? So this is the velocity of A just before collision. Now, collision occurs, and then I know the velocity of A just before collision, as well as the velocity of B just before collision, because in fact, guys, the velocity of B just before collision is 0. It was resting on the spring. All right? And I am sure that this is a central impact. Why? Because in fact, the plane of contact is X, and then the line of impact is y, or it's along y prime, and then I know that the velocity of A is along y prime, and B after impact will be also along y prime. And that's why, guys, I can say that this is a central impact. I can apply the conservation of linear momentum as well as what? As well as the coefficient of restitution, all right? So central impact between A and B, apply the conservation linear momentum and the coefficient of restitution equation. Let's just do it. So the first one is the conservation of linear momentum between A and B. This means that MA VA1, that I know because I found VA1 is equal to 2 radical GH, 2 radical to GH. VB1 is equal to 0, and this will be equal to MA VA2 plus MB VB2. This is my first equation. Now, the coefficient of restitution is given as E, then this will be equal to VA1 minus VB1, but VB1 is here. Right? So from the coefficient of restitution, in fact, I can find VA2 because the question is to find VB2. So I can find VA2, and then VA2 will be equal to VB2 minus E radical 2GH. And then, guys, I can substitute this equation right here to find VB2, right? So VB2 will be equal to MA radical 2GH 1 plus E over MA plus MB. Now the question, guys, is specifying the masses of A and B. They are saying, guys, that MA is M while MB is 2M, which means this ratio right here will be 1 over 3, right? 3, 2GH 1 plus E, right? So this is VB2 in terms of E and H, and VB2 will be in the positive direction of Y prime, which means downward. Any question?